Let's now talk about a related topic, variable length arrays. So, in early versions of C, all arrays had to have constant sizes, meaning that when you're defining an array, you had to supply constants to specify the size. But what happens if you don't know at the size at the time that you're writing your program at compile time? What if you don't know what the size of an array should be at that time? What if you want, for example, you want to use some user input to determine what the size of the array should be? Now, for that, we can use something called dynamic memory allocation, and we can use the malloc function for that. Another way to do that is using variable length arrays or VLAs. Now, once you declare an array using either dynamic memory allocation or using variable length arrays, you cannot change the size after that. Once declared, once created, you cannot change the size either way. But here's the thing, variable length arrays that we are looking at right now became available in a standard of the C language called C99, which was in the year 1999. It was a while back. Now, unfortunately, variable length arrays are not supported in Microsoft's Visual C++ compilers, which means if you're using Windows, which we are in this course, you won't be able to use variable length arrays. If you're using GCC or some Linux platform, then you can use VLAs, but not in Visual Studio. Nevertheless, there's really not much in the way of new syntax when it comes to variable length arrays that you have to learn. So I'm going to go through this very quickly, just anyway, so that if you do ever encounter variable length arrays, you know what you're looking at. So in this sample code, and I'm not going to do a hands-on section for this, of course, what we're doing over here in the main function is we are asking the user to for the length of an array, to specify the length of an array. And we store that in an integer called array size. And in the following line, we declare a one-dimensional variable length array. And as you can see, the syntax-wise, there's really nothing new. The only thing that's changed is that the size of the array is now being specified by an integer variable, something we haven't done before. Before that, we were either using constants or we were using symbolic constants using the hash define preprocessor directive, which really just evaluated to constant numbers. And after that, after doing this for a one-dimensional array, we demonstrate the same for a two-dimensional array by asking the user for number of rows and number of columns for a two-dimensional array, and then we define the two-dimensional array just like that, where the dimensions of that array are specified by these two integer variables, row 1 and column 1, that we have just read from the command line using a scanf function. And then we repeat the same thing for a second 2D array called array2D2. And then we print out the size of the first VLA, the first variable length array, And we see that we can even use the size of function for VLAs, and it'll return a number that is on a for an integer array. It'll return the number of elements times 4, because an integer typically takes up 4 bytes, or whatever the number of bytes for an integer on the system you're running this on. After that, we have a for loop that goes through the elements of the one-dimensional VLA and simply squares the index value and stores that in the corresponding element of the array. For the two-dimensional array, we have, for the first one, we use 2 nested for loops, and we simply add up the indices of each element of the two-dimensional array and store the sum in each place. And we do the same thing for the second two-dimensional VLA. Add up the indices and store those in each location. And we also have 2 other functions, one called print1d array and another one called print2d array, that take, the first one, print1d array, takes the one-dimensional array as argument, this one, I'm sorry, and also its size. You can see over here, unlike in the previous example, you can pass the arguments really in any order in which you specify them in the function prototype. So over here we are passing size of the array first, followed by a reference to that array. And the print2d array passes number of rows, number of columns, followed by reference to the array, the 2D array in that case. So we call these the print1d array function, and then we call the print2d array function for array 2d1 and array 2d2. And this is what happens inside the print1d array function. Simple enough. We're printing out all the values, 1 on each row, because there's a /n character over there, 1 on each row. For the print2d array function, we're printing out all the values on a line, and after completing each row in the inner for loop, we put in a new line using the puts function. So very similar to how we did it in the previous section on multidimensional arrays, where we were using 2D arrays. And if you run this program for input 6 for the first one-dimensional array, 2 and 5 for the first 2D array, and 4 and 3 for the second 2D array, you can expect to see something like this. So size of the first 1D array will be 24, 4 times 6. And the values in it will be set to 0, 1, 4, 9, 16, 25. So square of 1, square of 2, square of 3, square of 4, square of 5. And the values for the first 2D array will be something like this. And here are the values for the second 2D array. As you can see, other than the only thing that's different is that when the arrays are defined, the sizes of the dimensions of those arrays can be variables. That's really the only change. Other than that, whether you have a VLA or a static array, which is what we've been using before this, they're passed 2 functions in the exact same way. You still have to specify, you still have to pass the dimensions, the size of the array, in order for it to use it inside a function. And as for the dimensions of the arrays, the same rules apply. Array sizes have to be integers. And of course, they cannot be negative numbers. So this is just explanation of the code itself. But the key thing to remember is that the only thing that's changing is when the only place in the code where you can see that the arrays we used in this example are VLAs, variable length arrays, is in the statements where we are defining those arrays.